Get Bit podcast. This is Matthew, Philip, and then we have
Logan.
Will.
joining us today. They're going to be asking us some questions about tube benders, and we're hopefully going to answer all the knowledge that you want to know about tube benders.
Some of the questions we get asked on the regular: how accurate are CNC tube benders?
Well, your CNC tube bender, the accuracy depends on the size of the machine for one, but for most part, it's plus or minus one on your, or 1 thou on your carriage travel. And then you've got plus or minus probably about a 0.1 degree to half, or to 0.05 degrees on the bend angles. And then it also depends on your speed, your material, things like that. You've got spring back in certain material that acts a little different, but for the most part, the machines, they're typical CNC machinery. They are very precise, servo driven for the most part, if not servo hydraulic. So precision is there. The key that a lot of people miss, though, is their material plays a big factor in this. The stretch, whether it's welded, whether it's seamless, all these take factors, wall thickness, everything.
Yeah, and so with a couple of those points in mind, a question I get a lot from people who are maybe new to tube bending is just in general, CNC versus NC. Explain, why would I choose one versus the other? What are the benefits and the drawbacks of each?
So the difference in CNC and NC is going to be whether it has a carriage travel or not. Is it using something to place your linear dimensions and your rotational dimensions? CNC is going to have that carriage. We're going to be able to move. We're going to be able to change everything in that aspect. NC is going to have stops and flag stops set up so you can actually set your links, but they're going to be manually set by hand as well as your rotation. You're going to have to check your rotation as you go around.
Okay. And Philip, you mentioned servos and hydraulics. That's another question I get a lot is all electric versus hybrid benders. Again, which is right for me? Why would I choose one over the other?
Right. So, the idea of the old school was all hydraulics with very little servos. So now we're moving into the modern era. Everybody wants to go with these all electric machines, do away with your hydraulics. It also adds a benefit to it because everything is synced together, being the servos versus the hydraulics. We do see issues, like your hydraulic PDA with a servo bend die, they're going to jump out. So, unless they're proportional or they're servo hydraulics, they're not going to function the same. They're going to be bang, bang, they're going to go. So the big difference between the hybrid and the all electric is the all electric, you've got no oil, everything's programmable. You can set different lengths, positions, variables just by that. Whereas your hybrid machine, usually that is using a couple bang bang valves, things like that. But also it's just your clamping is the main thing that's hydraulic in the hybrid. You still got a servo bend, rotation, and carriage travel. So we see a lot more people in that. It's just a cost thing, more or less, for most people. Know what your budget's about. A lot of times people are concerned about speed with hydraulic versus electric. There are advantages to both, and both can be sped up to meet your needs. But an electric machine actually has to travel on a ball screw, and you actually cost some time in that unless you set up the distances correctly. Whereas a hydraulic machine and bang bang valves, you can move faster. It's immediate. You're up right then as soon as the valve fires. So those are some differences to consider as well.
And I would say probably maintenance is different between the two. I get asked that sometimes, what's the regimen like on a hybrid versus an all electric?
Really, in my thought, just, from a maintenance standpoint, there's not in my mind, a whole lot of difference in maintenance. Your hydraulic oil, you've got filters, you've got things like that. You can get traction valves, but you look at what Matthew was talking about, you go to all electric, you've got servos and slides and ball screws. It's just going to have to be greased and things like that. So, there's, in my mind, there's really not really much of a difference between the two whenever it comes to maintenance stuff. Because the hydraulic stuff's pretty cheap anyway, and you don't have to replace the oil as often as people think. Most of the time, the oil that's in your tank's cleaner than the oil that you're pumping in it new, because it's been filtered through the system. The main thing you got to watch out on the hydraulics is make sure your temperature's not getting hot. You don't want to burn that oil. You don't want to scorch that oil. Then you're going to have to change it. But other than that, you're just changing filters, and for the all electric, you're just greasing.
That's a good talking point, because another question that I get a lot is, how often do tube benders need maintenance, like preventative maintenance, or just day to day, week to week, month to month type?
All of our benders are actually going to come with a manual that depicts all of that. We recommend you grease them weekly.
There's other aspects as well. You want to check your bearings, your L's. You want to make sure all that's tight. You want to make sure it's performing properly.
Tooling alignment.
Yep,
It
tooling
costs you a
alignment.
lot of maintenance issues. If you're improperly aligned, it can cause bearings to fail, cause other failures like that. A lot of the stuff we see, a bender day to day running, if you grease it, you lube it up, she's going to give you many, many years. We're talking decades of use, as long as you don't abuse the machine. And that's the thing that people forget to look at. And a lot of these, going into robotic work cells, that's where we see a lot more neglect as well too, because people aren't standing there looking at it on a daily. So they're not checking these things every shift or checking them every time they come in, which is really what you should do. Do a small inspection before you start your run, just to make sure everything's in order. Don't depend on the guy before you on the shift before.
One of the things you mentioned right there was tooling alignment. And a specific example of that we see a lot is clamp dial. So when people set up their clamps and they're coming in to meet each other, if you end up misaligning your clamp and it comes in, it's going to continually pull up or push down on that die. And if you end up pulling up all the time, you're going to put stress on your bearings, you're going to put stress on your rails, you're going to put stress on the bolts that are holding them down. And eventually over time, it will wear that out completely. And it may take the life of your machine from 15 or 20 years to 5, maybe less. We also see problems with misalignment on the pressure die, and that's something we talk about in some of the tech videos, where when you've got pressure die misalignment, you'll actually get marks on your tube. If your pressure die is too high, you'll end up getting a mark on the top side of the inside bend die side of the tube, vice versa the other way if it's too low. So something to watch out for.
And that's all just more added stress to the machine.
That's right.
How long do the tooling and dies typically last? And then when you get into that, if you want to go over how the tooling actually all works together on the benders.
Well, I'll speak on the die last a little bit.
Yeah.
I've been here for 15 years and seen a lot of things come and go. But again, we come back to material. Material is a really big thing. Depending on what you're bending, a lot of people don't realize it, but copper is a really abrasive material. And it's also, depending on how the part's being used, the tighter the CLR, the more pressure you have to put on that tooling, the quicker that tooling is going to wear. We've dealt with other vendors of tooling. We make tooling in-house ourselves as well. We through harden our tooling. Typically, it's made out of S7 through harden. We get it up in the mid 50 Rockwell. And then there's other companies that use like 4140 and do a coating on the outside, or they just case harden the outside of it. So there's a lot of different aspects of how you can do it and what kind of tooling life you're looking for. But for the most part, we found that the S7, it does really well for overall. Now, if you're in a production cell, we may want to talk about different materials, different things, H13, A2, D2, DC53, but those are just some aspects. So really, there's no good answer for tooling wear other than, it's just dependent on application and material. But, you're going to get thousands and thousands of bends out of a die. There is potentials to break and crack and things like that happen. Especially these dies being hard. We try to double draw, but you take a die off a machine, you drop it on the floor, it has a tendency it might break. Or if you misalign it and get a tube caught in it, you can break a die, and things like that happen. They'll chip things.
Will talked about the tooling setup and what that's like and how they work together. So your typical setup is going to be clamp die, pressure die, bend die. And most of the time those are going to be a smooth bore through the dies if you're 3 times over the OD on your center line radius. Now, we do have other aspects. Philip mentioned the coatings there. Talk about carbonite coatings on the inside of the clamp die to really get you some more grip on that. There's a different wire spec for that as well. There's also a million different options for tooling other than the standard. We've got square tooling, we've got round tooling, you can do oval shape tooling. We can bend specific shapes. What do you call that shape there that we have on the desk?
Just an extrusion.
Yeah, extruded shapes. We can really tailor anything to any application, but it just depends on what you need.
Right, and you can watch some of our YouTube videos too. We've got like a standard tooling setup, just how to set your tools, how to go through that. It's really pretty easy just for a standard setup like Matthew talked about, and then we can get into mandrel bending with wipers, 1 ball, 2 ball, 3 ball plugs, and we can talk about that some more too.
What are some common operator errors that you see with tube benders and things that
There's a lot of common.
The operator errors are the most common.
Which ones can cause the biggest headache or the biggest problems, or maybe are the most easily overlooked?
I think you would have to break that down into categories like safety and then control on the HMI, what they've done, and then mechanical setup. I think those are the 3 big categories, and the one that's the most concerning is the safety. We go into a lot of facilities where, they've safetied a lot of stuff and you can't get close to the machine, or we go into facilities where there's almost no safety and they're reaching up into the machine, putting their hands close to the die, and that is extremely dangerous. I would rather see the machine wreck all the pieces and tear itself apart before I want to see your hand get smashed in there. And that's a common error that we see, is just people getting too close to the machine and being too comfortable with it almost. If you want to talk about mechanicals.
Right. And we do try to set these up with, whenever we sell a machine or sell a machine for our safety, we've got to go in and actually show them what they need to set up. But at the end, it's up to them. Once we leave, we can't dictate what they do. What were you saying?
Oh, the mechanical part of it. I mean, we see errors in people setting up their tooling wrong. We talked about that a minute ago, about how the dies can be misaligned. That's a big common error, and we get a lot of calls about, hey, my clamp is slipping, hey, my die's misaligned, hey, I'm getting these marks on here, how do I get rid of these marks? That's another common error for operators.
Right, just the people using it, typing in things wrong, and something else is the PDA. Some of the PDAs are programmable, depending on if it's servo or proportional or just a bang-bang hydraulic. And usually, the bang-bang hydraulic is where you see the most problem, because the people have to manually set that speed to travel with that bend die. So, if people don't understand, the bend die is what you bend around, and the PDA is what pushes your pressure die around as it's bending and as it's rotating. So if those speeds are off, you can push material or you can stretch material. And typically, on most cases, we want to start where we're feeling like it's a 1-to-1 ratio, like they're traveling together. And then you kind of look at your bend and then tell whether you need to push more or pull more. So, and just fat finger a lot of times on the HMI that they've mistyped a number or something in there, and it screwed something up, and they didn't calculate the length of the material, and it causes them issues. And a lot of times they get down a rabbit hole and haven't realized what they've done, and they can't figure out that problem.
Now, you talked about the servo PDA, and that's a big benefit to the 5 and 6A hybrid machines and the electric machines. In that servo PDA, as he'd mentioned, you can actually set how fast you want it to go. You can set how far you want it to travel. You can set the pressure that comes in on it. You just gain a lot right there, versus on a hydraulic machine, you have to manually set the pressure by hand, and you actually have to manually turn the flow valve to control the speed. And for operators that are switching a bunch of different tools in between and different centerline radiuses, a servo PDA can really help.
The different industries that utilize tube bending a lot, and then maybe common errors that you see, tube bending in aerospace is prone to errors in, this way because of the nature of the type of parts that they're trying to make. Or,
That's right.
yeah, whether it's aerospace or HVAC or whatever.
Well, and an auto, you want to talk about the industries, a lot of what we see is automotive, HVAC, boiler industries, mining industries. I mean, it's a little bit of everything, honestly.
Agriculture as well.
Right. There's tubing in about everything we do and everything that's around us, if you just open your eyes and look around. The biggest struggles with a lot of these are the tubing to some of these projects and processes are the last things that are put into the design. With your aerospace, they're looking at fuel rails and stuff last. Automotive, they're looking at putting exhaust in last. They're also looking at putting their heat exchanger tubes and stuff in last. They need to fix the big components in first, so this all gets pushed to the side. And a lot of the time you've got these engineers that don't understand bending and how it works and things like that. So whenever you're bending, you've got to have, like Matthew was talking about, there's a certain ratio for wall thickness to CLR to tube diameter that creates what what it takes to actually bend that, whether you need a mandrel, a wiper, things like that. And then a lot of engineers design with multiple radiuses too, which requires multiple tooling stacks. So, we try to get people like standardize your processes, standardize your CLRs. This will help out the whole design process, plus offset cost of tooling, what kind of machinery you need, things like that. Makes life a whole lot simpler if you can just standardize on some of those and know what you're up against when you're bending it.
What's the first thing you ask a customer when recommending a bender?
We won't know what you're bending.
Yeah,
Right?
yeah. Standardize.
That's kind of what I think we talked about before we started this podcast a little bit was, they've got to understand what they're bending, because this is the reason we're doing this, is so people can better understand what we're looking for whenever you're bending something. We're just looking in general for customize. There's not really a overall general die that's going to bend all the materials and all the tubing to.
I think that's a common misconception.
Right. A lot of people look like, well, I want to bend 2.5 diameter tube, but I've got variable radiuses. Well, why can't I just bend this with this bender? Don't you have like something that varies? And it was, no, because it's custom to the CLR, to the material type. And so everything takes into account those factors, all add up to determine what you need. So we build custom tooling, pretty much is what it is. There's no just off the shelf. Now, for most typical practical applications, sure, if you're bending a heavy wall material, and when we say heavy, we're not talking 1/4 inch, nothing like that. We're talking like 065 above. That's when you get into a heavier wall and don't require as much, and things when you get into that 2D and 3D, 2 times the tube OD and 3 times the tube OD, you don't typically see a lot of mandrels, wipers, things like that. So again, these are other things to take into account with that whole design process. That those are consumable items, and they're going to cost you more down the road because they're going to wear more.
That's right. And you can achieve variable radiuses with roll bending, but they have to be 7 times larger
At
than
least.
your OD. So keep that in mind as well.
Fun question for you. What's the hardest material you've ever tried to bend or see bend?
Titanium,
Let's
that's like I don't even remember if it was 020 ball, but it's
Well,
like
big
soda
face.
pop can, trying to bend it around something.
Yeah. I thought the project we did a while back with titanium nails for femur replacements.
Oh yeah,
That was a pretty interesting one with a really hard material.
right. That stuff just wanted to spring right back to where it was, and had to do multiple bends with it as you bend it to make a sweeping arc.
One of the other hardest things I've ever seen is trying to build greenhouse hoops. We were pushing
Roll
20
bending.
foot, roll bending 20 foot or 30 foot sticks of full rectangle. I don't even remember wall thickness, but it was pretty harsh.
Yeah, that was.
When doing that stuff, like, what's the best way to prevent spring back?
I mean,
Well,
there's
you
no way
can't-
to prevent.
Yeah, that's
spring
right. You can't
Or,
prevent it.
yeah, not prevent it, but
Mitigate
Minimize
it.
it.
So each tubing is, comes out of a lot of material. It's made in a lot. So typically you get those mil specs, you get that lot spec, and that material will typically all bend the same throughout. Something that people got to look out for too that causes other issues that we've seen is if it is a welded material, whether it's steel, whatever, location of the weld seam is critical, because whenever you weld a piece of tubing together, it creates a hardened spot within that material. So you don't ever want to put it directly on the inside, directly on the outside. We like to see it at about 45 degrees. Granted, some parts you're going to roll through some of those, but you've got to understand that when you're bending it, that weld seam can't compress as well as just the material whenever
Can't
you're on the
stretch as
inside,
well either.
and you can't stretch as well when it's on the outside. That's where you'll see tubes bust, things like that happen.
We also have problems with variable weld seams. If you've got, say, a square tube and the weld seam is not in a consistent spot, you will have very inconsistent results. So,
Right. So that's where your spring back comes in.
Sure.
You can, and these benders have things to compensate for spring back, but again, each lot of material varies. And that's something that people don't really understand when they start bending. It's like, oh, well, I know this CNC machine. Why can't I just throw that tube in there and hit the button and go? It bent fine on the last bunch of material. And the worst thing that we see customers do is combining lots of material. So they'll throw it into a big hopper, a loader, and an automated cell.
Yeah.
And then now they're having to say, well, why is this I'm getting one this and one that. And then you get to looking, well, you found out that they've mixed this lot of material, and now they're getting different spring back within that material.
A lot of times you can use the weld sim and the way it looks to identify different heat lots of material like that when that situation arises.
Talking about, just potential errors and things to watch out for, wrinkling and flattening. Like, what do we need to look out for to prevent that? What are some easy to avoid mistakes that,
Well, number one is pressure. So, if it's been designed to run without a mandrel, and then you're seeing wrinkles or flattening, typically it just needs a little more pressure. Things to watch out for too is once your dies get wore over time, they will wear in. And we have seen it to where the dies will go metal to metal. So the face of the bend die to the face of the clamp die or pressure die typically have a spacing. Depending on what size tubing it is and what size machine it's on, it varies anywhere from about 0.5 millimeter to, 3-4 millimeters. And over time, those wear and wear, if those get down to where they're face to face, you're putting more pressure on it, but your results aren't changing. So, and that's what a lot of people see. It's like, well, I've tried this. Well, what they're doing now, they're putting more pressure on the machine, more pressure on the tooling. They're just setting stuff up for failure. So a lot of times we'll have people bend the part, leave everything clamped up, and look back at the clamp die and pressure die just to see if they're metal to metal. If they are, you can't get any more pressure, so you're not going to fix anything. You're just adding to the problem.
And that's another thing about common operator errors is worn tooling. The tooling will get worn down, and you'll get a error like you're talking about where you get metal to metal contact, and they just can't get enough pressure, right? And then they're calling us saying, "Why won't it bend?" So.
And then then you start getting into, you're talking about the outside of the tube. That's where the mandrel comes in, and usually that's the first step. As it gets harder, as it gets more difficult. So the first thing you're going to start looking at is a plug mandrel. Then you're going to go to a 1-ball mandrel. Then you're going to go to a 1-ball mandrel with a wiper, and then a 2-ball mandrel wiper, and it goes on and on depending on how tight a radius you're bending, what your wall thickness is, whole 9 yards again. But those are all things that you've got to look at. Location of those when you're bending, like you're talking about flattening on the outside of the tube. We've seen it where the operators don't have the mandrel far enough forward. It's too far back, it's causing more collapse, so you can move it forward. And fitment, sometimes, we see that issue too, where they've changed vendors of material. You went from your mandrel being really snug inside this one vendor's tubing to the next one you could about throw it in, just because of the way it is, and that also adds to it.
When you've got a 5 thou or 10 thou tolerance on your mandrel, and then you've got a plus or minus 15 on your OD
right.
of your
it may not even fit.
Right. You may get a different lot that may not fit at all.
You all speaking about mandrels, kind of like that answers when you need one type deal. Moving into that, what's the tightest radius that you can get in a bend? And I know it depends on, it really depends on material as well, but
depends on the size of the machine as well too. That's right. A factor in that.
You want to stay 1D and above if possible. You can go below it, but it's going to be really hard to fight. It's really hard to deal with. We see a lot of people struggle with that. Typically, our machines are based on a 1.5D. That's how we set our tolerances, stuff like that, to look at the torque specs, things like that, which we do cross-section moduluses to look at the material, make sure the machine's right for it, things like that. But
it seems to me that a lot of customers don't understand how much the wire items are going to cost them over the longevity too. They want to do these really tight radiuses, and they want to have a 2 or 3 ball mandrel with a wiper. But in their design and engineering process, they didn't take this into consideration that you're going to have the wire items of the mandrel and the wiper that are going to cost forever on this project. I mean, what's the typical lifespan of a wiper and mandrel? It's really unknown until you get to bending, but you
that's right. The tighter the radius, the thinner the material, the quicker they're going to wire most of the time.
And it depends on the coating you get on your mandrel. It depends on what type of wiper you get, but that's just an added cost. If you can move away from it and do a 2 to 3D bend, you're going to be a lot better off and save yourself a lot of money in the long run.
What are features that you would say are like non-negotiables? If I was buying a bender for my shop, I would absolutely want this feature, whether that's
servo bend. Servo bend is number one. Well, there are benders out there our standard is servo bend, but there are older benders, and you can still buy new benders with hydraulic bend, using a servo proportional valve or an encoder. some sort of application like that, and they are just not reliable and not accurate. They served their purpose years ago. They were the height of technology, but nowadays we've got better things than that. Servo bend is the way to go.
Right.
For sure.
Definitely for speed too. Definitely been faster that way, but
More accuracy, more repeatability, faster. I mean,
less maintenance.
hands down.
The other thing, everything that we're moving to, also on the safety side of things, we used to have floor mats back in the day that you just threw like a 5x6 floor mat out in front of the bender, which really is legally safe by OSHA standards, but in most cases, let's not say all, but most cases. But anymore, that's just not enough to guard the operator, not enough to guard them. So we've moved to a CNC floor scanner, and that's our standard now, and that's why that's non-negotiable. Just because of that, we can program it out there to where it actually needs to be for the customer, and show them how to use it, how to utilize it to its full potential.
Floor mats get a lot of damage too. I mean, operators drop a lot of tubes. They're walking back and forth all the time. It's obviously a wire item. So if you put that out there and it gets damaged, which it always does, you're going to end up replacing that mat over and over and over again. If you can put that scanner in a safe place, it can reach out a good distance in a 14-foot radius all the way around for the SZ1. It's such an advantage, in my opinion. And you can configure it around anything that's out there. So if you've got a table in this area, you can configure it around that table if you need to. Whereas a safety mat, you get 3x5 and that's it. You don't really have any other options.
Right. And then you see people trying to load from the side, things like that present potential problems that are never in the safety zone.
Right.
Or we've went into places where they don't put the trim kit on the mat and don't mount it to the floor, so they've picked it up and run it around the back and scooted it up under the bender because it keeps tripping their safety, or they have to hit the reset button every time, make it inconvenient for them.
You talked about operator errors. One of the things you see most is people bypassing things. Instead of trying to fix it or trying to tell somebody about it, they'll find a way to work around it to keep going. And it's crazy the amount of things you see out there.
People ask a lot, what controller we pair our benders with?
Yeah, we pair our benders with Bend Pro Control from Current Tech. We find that to be the most user-friendly, American-made. I mean, you can read everything. They do a great job of putting descriptions on there and reasoning as to how these things work. The layout's awesome. There's a lot of controls out there that are a lot more complicated, hard to use. A lot of the Asian controls are point and click with pictures. Doesn't give you any type of description.
And also the good thing about it, the Bend Pro 2, is you can typically take it and put it on about any bender out there. So if you're buying a new bender from us, or you're wanting to retrofit your other benders, we can take that old bender and put that same control on it. That way, it becomes a standard across your floor too. Even if you have benders from different manufacturers, you can still put that control on most of all.
If you've got an 8 Leonard from 1980, we can put a Bend Pro on that, and you can have a brand new UTE Select bender with the same Bend Pro on it, so you don't have to cross-train a bunch of operators. They know how to run this control.
And that's something we see a lot too, is like turnover within facilities. So like no upper management knows how to run that machine. So they're at an operator level, and this is happens to us year after year after year. Is we get those companies we've sold to in the past, and now they've had a turnover within their operator. Now they've got nobody there that knows the control. We got to go back out and teach again. So if you're a plant with multiple benders, this would be a good opportunity to take and put that Bend Pro on all your benders. That way, now if you've got multiple operators, they can cross-train the other people coming in too. You don't have to bother us.
Yeah,
we don't have to charge you to come out and train you again.
I can't tell you how many times I walked in somewhere and they've got 5 or 6 different controls, and there's one guy that knows how to use that machine, and there'll be one over in the corner that they don't use, and I said, what's wrong with that one? They said, well, we lost all the operator for that one. Nobody knows how to run it.
Well, what's the worst thing too is like you show up at a place, you just install a new bender or just put a new control on it or something. You train the guy, the 1 or 2 people that are there. You turn around, you come back home, and 2 weeks later, that guy's already gone.
Yeah,
they're calling you back like, well, we need you to come back out.
Train somebody.
We were just there, but
and
it happens.
That's another choice that a lot of companies don't make right, is who they're training, and they may only train one individual. And in my opinion, that is an absolute mistake to train one person. You don't want to get your training so big that you can't train them all at one time, but anywhere in the relative neighborhood of 2 to 6 is usually appropriate for our trainings when we conduct them on the Ben Pro. But if you don't hire, or if you don't train more than one, you're messing up for sure.
Something else I'd, like to come back to you about Ben Pro specifically, because I've had this come up a couple of times, is networking within facilities. I think a lot of bigger companies specifically, they have pretty strict IT protocols. We see that also on lasers a lot, the PC based systems on lasers, and what kind of vulnerability that leaves you up to if you're networking those machines in. But talking about Ben Pro specifically, and benders and how that applies, like what kind of protocols are put in place, or safeties are put in place, how hard is it to work with those? Because Ben Pro, we know, offers remote programming and offline functions as well, and how easy or hard is it to make all those play nice with like a strict IT department?
It's really up to the company and the end user how they want to do it. But for the most part, it's a standard industrial PC, touchscreen PC, back off made. These things are very robust. We got great support with them. Um, we've never really had issues with anybody getting on them. The biggest thing right now is every time you get a new release of Windows, and then they don't want to keep up with the software, on the backside. So Current Tech's been really good about keeping that going. Right now they are at Windows 10. We haven't moved into Windows 11 yet, but I imagine that's probably coming out with the next release on the G3. But right now it's a Windows 10 base, but Microsoft is supporting it because it's an embedded Windows 10. So for the IT side of things, you can connect these to your network however you want to do. If you don't want it to be on there, you can either do a VPN or do even just one that we can tie into occasionally. Or if you want it networked in your system, that's totally fine too. There's ways to do that. You can block it off. A lot of people don't like us remoting in just because of that. And that's where we tell them, you can use a guest network or something like that and log in or something. But most of that's pretty much, you could run any kind of, there is some stipulations, to what kind of antivirus software you put on it, things like that. But for the most part, it's just like any other PC that you'd be dealing with.
Now, you talked about networking too. G2 V3 of Ben Pro gave the addition of IoT. So now you have IoT in your factory. You can link it with other IoT devices on your network, and you can get that information of, is it emergency stopped? Is it bending? What part's it on? How many is it at? Whereas G2 V2 did not have that.
Right. There's several MES softwares that'll read it puts out JSON files. There's 4 or 5 different files that they can read to look at just for that.
Thanks for joining us here on the Get Bent podcast.
Till next time, get bent.